compute. So let's walk through this one. This is uses for differentials is where this category shows up. It's in the differentials 13.4. So we can approximate things, values where like 1.03 and 1.98 is ugly. Who wants to do that? Well, it's kind of shitty, but doing 1.1 and 2 is kind of easy. And if we just use this formula, we can do a lot of the computations using 1 and 2, and then just throw in what dx and dy is. What's the difference between the 2 points? So just pick a path and be consistent. If you're gonna go like dx, like either do 1 minus 1.03 and 2 minus 1.98, or the other way around. To just be consistent. Don't do like 1 minus 1.03 and then 1.98 minus 2. You got to keep it going the same way. So this would be like our dx. And that a little clearer. We could use this for dy. So we'd have 0.03 for dx, and I'm sorry, negative 0.03 for dx, and 0.02 for dy. Go ahead and figure out using that dx and that dy rather than doing the other version. Figure out what dz is, because remember, delta z is approximately dz. Give you a couple minutes to do that. We'll do it together. Interesting. Did you guys get 0.42? Let's see how close it is. What is Z at 1, 2? It's 2 plus 16 minus 6, which is 12. What is Z at 1.03, 1.98? That's a calculator problem. .03 cubed times 2 plus 1.98 cubed times 2 minus 3 times assuming I did this right, which makes me wonder, did I screw somewhere up? That's a big difference. Those aren't close. Did I screw up some math somewhere? Six x squared minus 3y and 6y squared minus 3x. I plug in 1, 2, 6 minus 3 times 2. 6 minus 6 is 0. X squared is 4. 24 minus 3 is 21.
I think you got your actual value of Z wrong.
I have what?
The actual value of Z for 1.03, 1.98.
This might, yeah, I thought about doing that one again. Let's see. 2 times 1.03 cubed.
I'm already rechecking it. Yeah, I'm getting 11.59.
Yeah, I'm getting 11.592 as well. So I did make an error. Okay, so if we do, and we did 1, 2 minus 1.03, 1.98, following that same order, 12 minus 11.592. 408. So these are approximately the same. They're close. But I didn't need a calculator for this. In fact, the one thing I fucked up on in that entire problem was the calculator work. So like doing the approximation using DZ resulted in a better answer. If I had only done it once, I would have been closer with this one. That's how we use DZ to, or a differential to approximate an actual difference. Is there any questions on that? Let's have some fun. Does anyone need this up longer? Let me know. Word problem. Oh, that should say can. It got smudged. A normal soda can measure 4.8 or can measures 4.8 inches in height and 2.6 inches in diameter. How much error in volume could occur if the radius and height had a possible error of 0.1 inches? What's the percent error? I saw that Quinn likes to use Discord as well to work with you guys. I didn't notice him trolling any of you though. I need to talk to him. I need to up his game. So maybe a good spot to start is, what is the formula for the volume of a can?
That's a good question. Don't know.
And a soda can is what shape?
The cylinder.
It's a cylinder.
With
Volume of a cylinder is the pi r squared times the height. So B is a function of R and H here. And if we're checking for error in volume, we're checking for a change in volume. So we're looking for delta V. So what is R and H in this problem?
4.8.
4.8 and 1.3. Yes, make sure that you recognize that it's diameter listed above, not radius. Do you know it's National Taco Day?
Today. I mean, it's a Tuesday.
It's a lot of holidays.
We could have.
It's also World Space Week.
I feel like every day.
I can't eat space though. I could eat a taco.
You can eat the space between your taco.
What is coffee?
Doing stuff like how long it's you know what taco is. It's
Like, suddenly just lost my mind. I guess you can space.
They're hard burritos. That's what it's
hard for me to never clearly had. So isn't there soft tacos? Isn't there soft tacos too?
There you go. Down.
It's pretty good.
It's when you're too lazy to make a burrito, or you fail to make a burrito because it falls apart, so you decide to have a lesser dough taco.
Or it's I just like to call it food.
Hey, you can call it that too. What about you, Miss Jones? What would you define as a taco?
A taco? How would I define a taco? Tasty goodness. Tasty goodness wrapped in a flat tortilla.
It could be like a burrito piece. It's like flour and bring it together. pH and a BR or 100% like our possible.
This is how you wake up your class. You start talking about food.
Ravioli is just Italian favorites.
What kind of take is that?
Are you ready to dessert? It's a magic cake that has inside of it.
It's called a meat pie for a reason.
Steak cake and they use mashed potatoes as the frosting.
Okay, now that actually sounds kind of good.
Yeah, that's pretty good. With red too, so like, oh my god.
Hey, if you're gonna have mashed potatoes, you have to have gravy. Yes.
What?
What?
Yeah, I don't agree with that.
Yeah, it's like-
You don't put syrup in cake.
No, that's just like adding more sugar. Like, why do you want?
If you want,
I don't have.
it's like having cereal without milk.
You know, pancakes don't have syrup.
Okay, you put butter and syrup.
Say that like, yeah, pancakes I have like
For the.
No, these guys are something to appreciate. Mr. Jones, whenever we done, we've got an entire class of food debate.
I know, it sounds like I done fucked up and I distracted you.
I don't care about you.
Now, this is how I like to start my mornings.
So I factored out the pi. What do we get when we factor out the pi? So 2 times 1.3 times 4.8 times 0.1 plus 1.3 squared.
Touch grass. They're sad. It's that obviously. I'm outside. I'm lawyer law. All I know is we're getting fired from Coca-Cola.
Let's make sure we got that same answer.
As long as.
I already double checked your calculation.
Oh, okay, bad. Negative error. Okay. Run the assembly
Quiz
line.
it every time. So getting less and less.
Run the assembly line. It'll be fine. We all got different numbers.
From him? Because I got the same calculation.
Oh, yeah.
I didn't times pi though.
Right.
How do I calculate percent error?
Well, we gotta multiply by 8.
You put the two, I think you put the left, what is it, your estimate? Your estimate over your actual value or your actual value over your estimate?
It's the error over the actual value. That's pretty damn good. So we've got,
That's how you do it in, that's how you do it in chemistry. Your percent, you get out your error. There's 20 chemistry courses, that's it, and I just don't have everything down.
It's a great class.
Yeah, I probably could take one out.
You should take it. You should take it.
But I don't understand this. Yeah, that.
Actually, I'm taking it right now. I'm like, Sucks. I'm in a blast.
That just goes through that you're
I got a question.
yeah,
I got a question. So I saw the question saying the possible error is 0.1 inches.
that's what
And,
DR and DH are.
change to the radius gonna be half of that. Because diameter,
Nope, notice I very much specified radius possible error of 0.1.
Oh,
It
okay.
shows the
I
one.
would be-
Good catch, though. Good. I made sure I wrote radius here so that that would not show up. But you're right. If it did not say radius and height, if it just said 0.1 inches in each, you'd have to go, are they saying 0.1 inches in diameter error?
Then
And
it's
maybe
gonna
change
be wider,
DR to be
right?
0.05.
Okay, gotcha. All right. Everything's wrong.
Also,
Wait,
Lauren-
I don't think.
Also, Lawrence, I'm not a psychopath because her class is not as bad as Quinn's. I'm not a psychopath because her class is not as bad as Quinn's.
I wasn't.
He's not gonna ever see.
She's already moved on.
What?
Nothing. Just internal conflict.
Oh, okay. All right, here we go.
Seems like quite, that's like almost, that's a little over 1/6. Just having a slight change in the dimensions of the can could drastically change the volume.
Wait, why is that in square?
That's. Oh, wait.
Like I said, it's volume, right?
Yeah.
I mean, oh, yeah, I think, do you think that's inches cubed instead of
Inch
inches
cube
squared?
every time after we take derivative.
Because this is
it's
the
inch
change in
squared.
volume.
BR and BH, blah, 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 like.
If this is a change in volume, would that not be in inches cubed rather than inches squared?
Are you happy?
Yes.
Lawrence says he's not happy enough. He needs more.
Lauren, I'm hearing Lawrence wants a hard problem on the test. No, you know who's asking for a hard problem on the test? Charles. Charles took down my post about being the defense of the dark arts against the dark arts in the physics channel. I'm bitter.
Privileges and he's fucking still crazy. Who is Charles? There's a Joker line somewhere there and there. but I don't know.
You guys ready for another local linear approximation?
Wait, what we found out is that like, is that pretty terrible? 17%?
That is a pretty large percent error. How much, like, really?
Well, you gotta figure 0.1 inch radius error means 0.2 inch diameter error. And the diameter, that's like almost 10%. It was 2.6 inches in diameter, and we could have a possible error of 0.2 is almost 10% error in the radius. So, and the radius, the effect of the radius on the volume is squared. So it is a pretty large thing.
So that getting smaller and smaller, right?
Oh, local linear approximation. This is the formula for local linear approximation. In case you guys didn't take good lecture notes, I copied down or wrote down the formula for you. How do we approximate a function at a nearby point?
You see, yeah, so this is the equation I learned of linear approximation.
And this format makes it a linear approximation.
Yeah.
So approximations in general don't have this x minus x naught and y minus y naught.
Yeah, typically it has like delta, a change in x and change in y, or dx and dy.
When we get to 13.7, after you've learned the gradients in 13.6, we'll see how we can approximate the normal vector on a plane using local linear approximation, using gradients. Good stuff.
So.
I love gradient.
Well, that's a spirit, Jericho. You gotta love gradients before you learn it, because you'll hate them afterwards. You might hate them afterwards.
I see the ring. Please.
So, so it's like a one.
And I'm gonna do this right here. I'm gonna change the color on this because I want to make it very clear you do not put anything in for that X and that Y.
So I
Those
wasn't right.
stay as variables. So we leave those alone.
So there's the- That was you guys got your partial, so. What's it? X naught or the 1.03? Which one? Oh, so it's just the one. Because you're subtracting the naught and the X.
No, it would make
That's
sense
fine.
more
I was
sense
just
that
checking my
the
part.
X naught and Y naught to be the regular 1, 1. I mean, no, yeah, that actually definitely makes sense. Because the X, Y would be the actual with 1.03 and 1.02. Yeah.
That's fine. Which ones are X naught? This are X naught. Or is this right?
Which one is that?
Think about it this way. See, like, look at the linear partition is gonna be of the actual value. Of the actual equal. It's gonna about equal all that because you're using the regular 1, 1 using with the.
This one, 1.03 or 1.03.
Oh, yeah, it goes into X and Y, regular X and Y.
Oh, why? And that's nice.
Benjamin Levy.
Ben, where you going? I got a question for you.
What question?
How did you do this?
I did the partial derivative and then plugged in the numbers.
Did you do the partial derivative as is?
The derivatives look right.
Or did you recognize, I'm betting you didn't, this is x minus y cubed.
And the same thing.
All right, now you can leave.
Oh, so I was right then. I said that was a polynomial. Where you could like you could try.
This is a polynomial. It's definitely a polynomial.
And you could just
So there's a couple ways you could have gone around doing this. The straightforward brute force method, 3x squared minus 6xy plus 3y squared. We got negative 3x squared plus 6xy minus 3y squared. And notice if you had done it this way, oh, Mr. Jones, you were such a sneaky bastard.
That's what we went for yesterday. I thought we figured it out. It will come.
But this makes approximating f of x at 1, 1 and 1 and f of y at 1, 1 pretty easy. Well, that kind of ruins the problem now, though, doesn't it? That's rude. This turned out lame. I thought I was being fucking clever. You know what? Let's make this positive. This is gonna zero out everything. Let's make these positive. That makes that positive.
They just trying to figure out.
Well,
instead of solving it, change the problem with these.
It's just making anything you had negative into a positive.
able to do this on the test.
Can we do this on the test?
No, you can't do it. Some of you did do it on the test.
When you don't like the problem, just make it better.
Well, it kind of makes a lousy lecture or lecture example when I zero out almost everything in the fucking problem.
I'd say make it for a pretty accurate lecture example. Most classes. Doing all the easy problems in class and giving you all the hard ones.
Why am I writing in? What is f of 1, 1? F of 1, 1 is 8. Maybe I should put it just so it's clear what I'm doing.
That's right. Because we're gonna speed run it like the last day.
No.
On Friday, it was all wrong, so I had to redo it all. Sure.
F of 1, 1 is 8. What is the actual value there? Let's find out.
Oh,
So when you're doing the local linear approximation like this, the 1.03 or the off points that you're checking out don't really come in until the end. An advantage of doing it like this format rather than the other ones, is that I can check a variety of points near 1, 1. I could immediately modify this to check 0.98, 0.97. So I can check in this small range around. The further away we get away from 1, 1, the less good this approximation works. There is some sort of radius of, I don't want to say convergence, but it's in that idea. It starts losing it begins to lose its accuracy as you get away from a certain radius around it.
calm down.
Universe.
One point zero.
What's wrong? I think it's 211. Not fair. So we're usually upstairs until 4. I can make it fair. Thursday, Friday, we're here. Yeah, I think that we.
You guys have any questions? Otherwise, that's it for today.
Live in a reality.
It's like a.
It's not yet. Friction. So they don't like it. I told you that, dude. Don't say red words. I think it's a bit.
I already know that.
It makes sense though, dude. Right?
Yes. Static friction. I love static friction.
This actually would have worked well with the x minus y cubed too, but it like takes away all the work here, but the accuracy of it's pretty good. Have a good day, everyone.
All right, see you later.
All right, since it seems like nobody has any extra questions, I will sign off. I'll
Okay,
see you tomorrow.
see ya.